Hello everyone. Today we'll be trying to understand how to calculate the number of atoms per unit cell. Let us start with the first type of unit cell, that is the primitive cubic unit cell. Now as we know, a primitive cubic unit cell has 8 atoms at its corner. That is what we have learned last class. Now if you can see figure 1.8, they have shown one particular atom, one particular corner atom. That corner atom is not just a part of one unit cell. As you can see, it is a part of 8 neighboring unit cell shared equally among the 8 unit cell. As a result, since each corner atom will be shared to 8 other adjacent unit cell, 4 on the same layer and 4 on the above or the lower layer, as a result only 1/8 of that particular atom actually belongs to a particular unit cell. That means the corner atom is contributing only 1/8 to a particular unit cell. Now since the contribution of a corner atom is just 1/8 to a particular unit cell, so what we can see now is, in all, since each cubic unit cell has 8 atoms on its corner, therefore the total number of atoms in one unit cell, if we try to calculate in one unit cell, we know that in one unit cell we have 8 corner atoms. 8 corner atom, one particular atom contributes only 1/8. So 8 into 1 by 8 gives you 1 atom. Hence, one simple cubic unit cell contains only 1 atom, not 8 atoms. To understand this, let us try to see a three-dimensional representation. You can clearly see a simple cubic unit cell. What you can see is a open structure of a simple cubic unit cell where the particles are depicted at the corner or shown as a point. But in reality, this is not what is happening or how a unit cell or how a simple cubic unit cell forms. This is what we do to understand the geometry of a particular unit cell, where we depict the atoms by points and join them by a line so that the geometry becomes clear to us. Let us try to see what happens if we try to see how actually a unit cell forms. So the 8 atoms which we see as point actually are not points, but the center of that particular atom which is present in that position, which we can see in this way. See, you can clearly see that the points which we are looking just in the previous diagram was not the point actually, but they were the center of that particular atom, which you can see clearly now. So this is what is the actual picture of a simple cubic unit cell. Now if I try to figure it out that how many of this 8 atom, how much portion of this 8 atoms are actually present, as we have done just now, that we know that one atom, one of this atom, one of these corner atoms will be shared to 8 other adjacent unit cell. So if I try to take the 1/8 part of one atom, so what you can see is, see, that is what you will be getting. So in one unit cell, actually you get just 1/8 part of each atom. So you can see that there are 8 1/8 part of atom, which we multiply. So 8 into 1 by 8 will give you 1 atom. So this is the 1/8 part of the atom we have 8 such atom, that is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 1 by 8th part, which we multiply, we'll get 1 atom.